Hello everyone. So today we will learn about the Terraform Provisioners. So Terraform Provisioners are a set of tools within the Terraform infrastructure as a code that allow you to perform actions on the local machine or remote resources during the provisioning or destruction phases of infrastructure deployment. Provisioners can be useful for tasks that are not directly supported by Terraform's declarative language, such as running scripts, executing commands, or performing configurations management tasks. So in this session, we will learn the Terraform, different types of Terraform provisioner, that is local X provisioner, remote XC provisioner, and then a creation time and destroy time provisioner. This will also be learned in this session, and we will see how the failure behavior of provisioners works. So the first one is types of provisioners. In Terraform, the local XC and remote XC provisioners are used to execute commands during the provisioning process. These provisioners allow you to run scripts or commands on either the local machine where Terraform is executed or on remote resources. Local XC provisioner. In the local XC provisioner, the commands are run on the machine where Terraform is executed. It is typically used for tasks that are local to the machine running Terraform, such as initializing resources, configuring local services, or generating files. So we will see the practical about this. So basically, the local XC provisioner is used in the real time for the Ansible playbook, and where you cannot use the standard format of the Terraform module, or you can say the runs. For there, we need the configuration. So we are using this local XC. So now let's go to the practical. So here I have created the folder name provisioners, and in that I have created the local xc.tf file. So I have copied the code, my AMI ID, and copied this syntax from the Terraform official page. And here I have provided with the syntax. With this, this command will execute the EC2 instance, and you can use this for the providing the directory, or you can say the path for the your repository. So now let's open the terminal. Okay, now we will use the AWS configure. I have already saved my secret key, access key. Okay, now we will run the command Terraform initialize. So it will initialize the backend till we have to wait. It's taking time. Let's see how much time it takes. Okay, so initialization is good. Let's apply the further command Terraform plan. Okay, so now you can see one to add. Now we will apply Terraform apply command. Here you can use a Terraform apply with auto approve if you don't want to enter the S value manually, but I am going with the apply only, and I will provide here S. And let's see, yes, so our EC2 instance is going to create. Let's wait till it gets ready. This configuration is used, and now you can see our resource is created. Let's go to the management console, and here in the EC2. Let's refresh this and you can see, yes, our instance is created. It's still initializing. It was created just now. So let's go to our code editor, and here we will apply Terraform, destroy with auto approve. But wait, the instance is still initializing. So we have to wait till it in the check will get passed. You always see here 2 by 2 check. We are not seeing it now. So we have to wait till the status check is passed. And then we will apply the Terraform destroy command. It's still initializing. Let's see one more time. Is it ready or not? Okay. So our instance is ready. So we will destroy it in our local machine. That is Visual Studio Code. Now we have destroying the EC2 instance we have created. You can see it is showing that one to destroy. In this way, we have created the local XC and we have destroyed the sources also. Now we will learn remote XC provisioner. So remote XC provisioner on the other hand runs commands on a remote resource typically using SSH. So for this purpose we will use this remote XC provisioner for Linux, then for Windows. This is useful for tasks such as installing software, configuring services, or performing other actions on the remote server. So for that, we will need the SSH key pair, then firewall rules for which the traffic port 22 allow, and then we will copy this syntax. So let's see in the AWS management console. In the key pairs, I have already created the key name demo. And I have created the key with the .pm extension. So keep this in mind. And you have to securely save the downloaded key pair, as we will need it to log in to the connect to the EC2 instance. So for that purpose, we will need this demo key. So now I have created the folder called new folder. You can give the name whatever you want. And in that I have created the file main.tf. Over here, I have copied the syntax from our article and just pasted it over here. And also the demo.pf file, as I told you, I have downloaded the demo.pf and just copied the syntax of that file in the demo.pf. Now, here I have given the required version, the provided, in the resource block, we are going to create the EC2 instance, which have the name example. I have given that in the tags, and the connection and provisioner block, I have copied it from the Terraform official document. So in connection, we are going to use the SSH. The user here is default EC2 user, which is for the Linux, and for the Ubuntu, the default user is Ubuntu. So the provisional block, here we are using the remote XC for installing the Nginx software. Now let's go to the terminal and new terminal. So we are in the new folder now. we will initiate the command AWS configure. For this, you will need the user which have the access key, secret key. So I have copied my user access key and secret key. So I will copy this. Okay, sorry. Just delete over this. I will copy the access key and paste it over here. And the secret key also. Default region, I will go with the default JSON output. Okay, now we are configuring the AWS. Now we will apply the command Terraform initialize. Okay, so it will install the required plugins. Okay, now we will apply Terraform plan. So you can see in plan 1 is add. So what that one is the EC2 instance, which is going to connect with the remote XC server. And now we will apply Terraform apply hyphen auto approve. With this command, you don't need to add the S after applying the Terraform apply. It will automatically generate and apply the services which we have executed in plan. So let's hit the enter. So here you can see the AWS instance is going to create. It will take time because we are going to install the server in the same syntax. So we have to wait till it get created, the server is installed. After server will get installed, we have to go to the AWS management console to check whether the server is installed is not. Okay. So our remote XC is connected. This message displayed, that means our syntax is correct. So you can see our server is installed. Now we will see in management console. So let's go to the EC2 dashboard and here in instance. Okay, so our instance is initializing. Okay, so instance is in running state. Now we will copy this. If you want to connect to the SSH client, so we are going to connect it. For that, see over here, we have to in security manager, just check once. As I have not provided any security group in the syntax, so we will the EC2 group create the EC2 instance created over here will be get the default security group. So in the default security groups, we have to open the in the inbound rule the port which is the 20 and 80 and the all traffic rule allowed. So let's before launching the EC2 instance, go through this security group and check once. I forgot to show you before launching the instance. So keep this in mind also. Now we will go to instance again. And here, this is our instance which we have created. And click on the connect. And now we will copy this. This will connect to the SSH client. So let's copy this. In this, the public IP address is shown and the region in which the EC2 instance is created. Now go to our terminal and here we will just paste this and we'll hit the enter. So now we have to press the yes. Okay, so the Amazon Linux machine is installed and the EC2 instance is connected to SSH. Now we will go to management console again and here we will copy this public IP address and let's open it in the browser. So this message is displayed that is welcome to Nginx. That means our server is installed. Now again go to terminal, that is CLI. Here we will press exit. So we will exit through this machine and now we will run the command terraform destroy to destroy the everything which we have created with auto approve so that we will don't need to give any yes and let's hit the enter. So let's wait. The destroy is complete. Okay, so this AWS instance is now destroyed. The message is displayed over here. So in this way, using the remote XC, we have installed the server and we have cross-check it while running the public IP in the browser. So now we will learn about the Terraform, different types of Terraform, that is creation time provisioner and destroy time provisioner. So creation time provisioner are executed during the creation or provisioning of a resource. They are used to perform actions on a resource after it has been created, but before it is fully ready for use. Common use case for creation time provisioners include initializing software on a newly created machine or configuring a resource immediately after it's created. So basically, this creation time provisioner, we have to use it while in the starting of the syntax. We cannot use it afterwards. And the destroy time provisioner are executed during the destruction or deletion of a resource. They are used to perform cleanup actions or to gather information before a resource is destroyed. Common use case of destroy time provisioners include removing resources from load balancer, taking snapshots, or backing up data before deletion. So destroy time provisioner in real time are used as in the antivirus service. So if a resources is created, till then the antivirus is in use, and when the resource is destroyed, automatically the antivirus connected or attached to it will be stopped. The antivirus service will stop. So now let's see the practical. For that, we will copy the syntax and we'll store it in a new folder and we'll open it in a Visual Studio Code. So I have already copied the syntax in the creation and destroy.tf name file. And I have also have my demo.pem key file. And now we can see over here, the provider is AWS. This is the basic syntax. The region access key and secret key, you know now. The resource, the AWS security group will create, and this will the ingress, which means it will connect the SSH client or the security group, with security group, it will connect to the EC2 instance. And the egress rule, the egress block provided, this is used for the net connectivity. And with that, the AWS instance will get created. You have to replace the AMI ID, instance type, and key name uh, as per your customization. And the provisioner here with remote exit, we will install the nano package. And when the destroy is applied, the package will also remove. So we don't need to manually destroy it. And in the connection, we are going with the SSH. That's why we have provided here the demo key, the, the private key, that is the file and the path for which the demo key. And now we will go to the CLI, or you can use the CLI provided in the Visual Studio Code. And now here we will apply Terraform, initialize first. Now we will apply Terraform plan. So let's wait till the plan get executed. Okay, so now you can see here in plan, the security group is going to create, the instance will get created. And here we have allowed the security port 22 for SSH, and the internet connectivity. For that, we have provided the egress over here with the port 65535. And now this will create the two. So let's apply Terraform plan. Sorry, let's apply the command Terraform apply with auto approve. Hit the enter. So now this syntax will create the EC2 instance, will attach security group to it, and this security group will then allow the SSH client, and with that the nano package will get installed. So it will take some time as it's going to install the package also. Let's wait. So now you can see over here 0 to destroy. So when we apply the destroy, Terraform destroy, it will destroy the EC2 instance and all. But with the destroy providers, when the EC2 instance is destroyed, the package reference to it will also destroy. It's taking more time. Let's wait. Okay. So the error is shown over here, which state that I was not exit status or exit signal from the nano package which I have installed. So because of 2 to 3 terminals open in the background, this code is not validating. I have closed the terminal. Now let's apply the Terraform apply command and see whether our plan gets executed or not. So now this is destroying the EC2 instance created, and the second one is adding, that is after destroying it will going to uninstall the package of nano. Let's wait till the plan get executed. So you can see the instance is tainted, so must be replaced. The message is displayed. So tainted means if the creation plan of the Terraform syntax failed, this message is displayed. So you can see this in the TF state file also. So now the EC2 instance is being replaced. In the plan, before we created the syntax, we can see over here, they showing 2 to add and 0 to change and 0 to destroy. But now it's showing like 1 to add and 1 to destroy. Okay. Now we will see the tainted. What is the status of tainted? For that, we will go to our syntax. Let's close the terminal. And here, we will remove this egress block, which is for the net connectivity. We will remove this block intentionally so that we can see the status of tainted. Okay, now let's save the syntax. And now open the terminal. And here we will apply Terraform apply with auto approve. Let's hit the enter. Okay, so now you can see with the Terraform apply, the tainted status is shown over here. Now let's check it in TF state file. In TF state file, scroll down, and here you can see the EC2 instance is not created and the status is tainted. So now in CLI, we will type the command. Let's paste it. and we will replace with the IP address which we have created for the instance. Let's go to the management console, and here you can see the instance is created. Okay, so okay, we will copy the public IP address and we'll paste in our syntax. Okay, and here this is the key name, that is demo, and the IP address of our instance. Let's hit the enter. So in this way, we have seen the creation and destroy time provisioners. Now we will go to see the failure behavior of provisioner, that is continue, and the fail, that is hard fail. If the on failure attribute is set to continue, it means that the Terraform will treat the failure of a provisioner as a soft fail. In case of a soft fail, Terraform will mark the associated resource as tainted, but will continue with the execution of subsequent resources and provisioners. The provisioning process will not be halted entirely. The second one is fail, that is hard fail. If the on failure attribute is set to fail, it means that Terraform will treat the failure of a provisioner as a hard fail. In this case, a hard fail Terraform will stop the provisioning process immediately and the entire apply operation will be aborted. So let's go to the practical. We will copy this syntax, which is we have seen in the previous types of provisioner, that is creation and destroy time provisioner. So let's go to the new file, new folder, and here we have created the file name failures.tf, and with that the demo.pem file is also created, that is key. So now let's open the terminal. And apply the basics command. As we have copied the same syntax, and we have removed the egress block, which is for the net connectivity. So this nano package will not install, that is the syntax will not run. Let me show you the one. So here we have removed the egress block. We just have the ingress one. Let's go to the terminal again. And now apply the Terraform plan. Now let's turn the Terraform apply with auto approve. So in this syntax, as we have not provided any failure block or attribute, this is a soft fail. That means if the plan is not according to Terraform, till then also it will create the resource. See, you can see over here, it's creating the resource. Let's wait till the EC2 instance is created. So you can see the nano package is installing because it's a soft failure. Let's wait till the complete program package it executed. It's taking more time. So now we will add this on failure attribute, that is continue. With this, if the egress rule or egress block is not added, then also the nano package will get installed. Let's see. It's taking more time. We have to wait. Now you can see after 12 minutes, uh, the resource is not executed. The error is shown because we have not provided the egress block. Now let's go to the code again. First, we will close this panel. And here in inline, we will add the attribute for failure. Let's copy this from our article. See. So we will copy this on failure attribute and paste in remote XC provisioning. Now let's save. Now let's open the terminal. We will exit the previous one. Okay. Now we will apply the Terraform initialize. Let's wait till it get initialized. Now we will apply the Terraform. Apply with auto approve. Let's see. Now this time, as per our definition, when we use the continue init, the Terraform will execute the plan. And in the previous one, we have not provided any attribute, so the error is shown. So now let's see if the resource is created or not. Okay, so you can see the resource is created. In this way, we have seen different types of provisioners and see and also had the demo about it.